Welcome to this video on factor formulae. Now the factor formulae are found on the formula booklet for A-level under trigonometric identities, and it's these four formulae under here, and these are often overlooked and not recognized or used when in fact they can be incredibly useful for particularly integrating trigonometric functions. And I'll show you how in a moment. So to start with, let's take one of these and just show how it comes about, how to prove it really. So I'm going to begin by taking the first one here. Sine A plus sine B is 2 sine A plus B over 2 cos A minus B over 2. Okay, so this is how we start. We take the addition formulae, which are right at the top of that list, and I'm using P and Q here. So we're using these two formulae here, and we're saying that sine of P plus Q is sine P cos Q plus cos P sine Q, and so on. And these have been proved in a previous video. Now I'm going to take these two expressions and add them together. Okay, and you'll notice that that will give me that expression there, that equation there. And these two terms cancel out. These two terms are the same, so it's double, hence the 2 there. Okay, and now I'm going to make a substitution that A is going to be P plus Q and B is going to be P minus Q. Okay, so when I bring that across here, we're going to use that and work out expressions for P and Q in terms of A and B. So what I'm going to do is add these two equations together, and that will give me an expression for 2P, and when I subtract those same two equations I get an expression for 2Q in terms of A and B. And then I just take each of those and halve them to get expressions for P and Q in terms of A and B. All right. And having done that, all I need to do now is replace the P plus Q and P minus Q and the P and Q here with expressions for A and B using this information here. And that gives me the result that I have in this box here. And that result there, of course, is the same as the first of these four factor formulae. And you can prove the other three just as easily using the same kind of method. So this is really useful when you come to do an integration of the product of trig functions. For example, let's take this one here. You've got to integrate the sine of 7x multiplied by the cosine of 5x. Now you might think, well, I need to use the integration by parts method, which you can do, but it would take you some time. Instead, a much quicker way is to match this up to one of the factor formulae. And if you look at that carefully, you can see it matches this one, which is this one here, except we also have this factor of 2 that we just have to take out. So that's easy enough to do. So let's proceed with that now. And I've got to say, well, 7x has to be A plus B over 2. And 5x has to be A minus B over 2. Well, if I set 7x to A plus B over 2, then I'm saying that 14x is A plus B. Okay, and similarly, I would have that 10x would have to be A minus B. Okay, and solving those simultaneously, it's very easy to find that A plus B is 14x, so therefore A is 12x and B is 2x. So my integral can be rewritten like this. I'll take out the half to compensate for the 2 that's here, and I'm now using the left-hand side, which is the sum of two trig identities, two trig functions. So it's sine A, so it's sine of 12x plus the sine of 2x. So it's now the sum of two items added together, both of which can be integrated easily. So taking that to the next line, I'll keep the half outside, okay, and inside a square bracket, the integral of sine 12x is negative 1/12 of the cosine of 12x, and then I've got to integrate the sine of 2x, which is minus a half times the cosine of 2x. And then, of course, there will be a plus c at the end. And that's it. And you could tidy that up or rearrange it. And it's easy to do because you're dealing with the simple integration of a single trig function rather than a product, which would require a lot more work. Okay, so that's one of the uses of the factor formulae. They're often overlooked and forgotten about, and yet they can be incredibly useful. So I hope that was helpful. Take care.